Hi, welcome back to O-Level Elementary Mathematics. I'm Christina here. Today we'll be starting on a new topic on Pythagoras Theorem and Trigonometry. So in this video, I'll actually go through some the Pythagoras Theorem and also introduce to you the simple trigonometry ratios. So without further ado, I will start today's video itself. So for Pythagoras Theorem, I believe it's not foreign to any one of you, especially you have seen this for many times, and it has it serves as a very good function, good theorem that you can actually apply in a lot of situations when there is a right angle triangle. So you just have to take note that when you want to apply this, it has to be a right angle triangle. Students tend to like to anyhow use the theorem itself when they, even though the question already stated that this is not a right angle triangle or this is a right angle triangle. Okay, so just remember the longer side is called a hypotenuse. The formula itself, I believe many of you all will remember by now. The two shorter sides, the square of the two shorter side equals to the square of the longer side. So it's AC squared equals to AB squared plus BC squared. Important to remember because it's not inside your formula sheet. Okay. So moving on, I'll go through. I'll actually talk more about the trigonometric ratios, which is very important also in trigonometry, especially when it's involved when right angle triangle is involved again. Okay, so for right angle triangle. Okay. So first, I would like to go through the first ratio. Sin x equals to opposite side over hypotenuse equals to AB over AC. So what is opposite side? So if we look at this sin x, so the angle that we're actually looking at is sine itself. The angle that we're looking at is x. So the line that is opposite x will be this. Okay, so you consider this as O, opposite, and this is our h because this is our hypotenuse, the longer side, right? Okay, so for BC itself is actually called the adjacent side. So it's important, this is actually a ratio, so it's actually something over something. Okay, just remember, it cannot be more than 1. Okay, especially because sin x, the maximum is 1. If you know your sine curve, okay, the maximum and minimum is actually 1. Okay, just some additional information for you. Okay, so just remember it's always a ratio, so it must be less than 1. So whenever your ratio is more than 1, you will realize that you can't actually compute the x itself, or you can't find your angle or one of your answer itself. Okay, so be very careful with this, because sometimes we tend to forget what is the ratio itself. Is it hypotenuse over opposite side, or is it opposite side over hypotenuse? So it's important to remember. So we usually use this kind of short form, so to remember it. So how I remember it is that S represent my sine function. I'm using the sine function. O represent my opposite, and H represent my hypotenuse. Okay, so moving on, tangent x itself. So tangent x, opposite side over adjacent side, so it's actually AB is here. Okay, then AC, adjacent, so it's actually AB over BC. So same thing, we have another acronym that you can remember, which is TOA, TOA. So remember, T is tangent, O is opposite side, and then A is the adjacent side. Last but not least, cosine x. Okay, so it's adjacent side over hypotenuse, so it's BC over AC, sorry. Okay, so it's actually CAH, car. Okay, car, because C is represent cosine, A represent adjacent side, and then H represent the hypotenuse. Okay, so it's important to know which angle you're looking at, and then you have to identify accordingly your opposite side, your and your adjacent side. Okay, hypotenuse is always the longest side of the triangle, right angle triangle itself. So it's important that you recognize your opposite side and adjacent side properly. Moving on, let's have some practice. Take some time, maybe just 2 to 3 minutes on this question, and I will go through with you step by step on how you can go about doing this question. It's one of the simplest question already. Okay, so in topic 6 itself, I'll actually go through a few examples, and then difficult questions will come in the summary video itself. So please do take a look at this summary video, which is at the end of the whole 4 series of our trigonometry itself. Okay, so now I'll go through the question itself. So for example 1, we actually need to find length AC, angle ACB, angle CAB. Okay, so let's do one by one. So for the first one, so for example 1, find length AC. So we know that AC is actually the hypotenuse. So we know that we can actually apply Pythagoras Theorem. AC square equals to AB square plus BC square, which is 6 square plus x square, which actually gives you 100. Okay, so AC is actually equals to 10. Okay, this is very simple, or just applying the formula itself. And then for question B, okay, AC square, ACB, angle ACB is actually angle X. So we can actually apply the trigonometry ratio that was taught previously. So now we look at angle X. We always want to use the numbers that are given. So the given number is actually 6 and 8. So 6 is actually the opposite side of X. And then, so this is my O. Then this is my adjacent. Okay, so I want to use these two. So when you think of opposite side and adjacent, you must immediately know which ratio you want to use. So in this case, the ratio will actually be tangent X, because I'm finding for X itself, which is angle ACB. So it's 6 over 8, which is actually opposite over hypotenuse. Okay, so what we do is that on a calculator, we actually find the inverse function of tangent, which looks like this. Okay, 6 over 8, and we'll be able to key in the answer, or key in the numbers, and we'll be able to find that angle ACB is actually equals to 36.9 degree. And always remember that we always must leave it in 1 decimal place. Okay, always check that your calculator, the mode of the calculator is actually in degrees and not in radian. If not, you'll not be able to get the answer itself. So you'll find that your answer will be very small because it's in radian. Okay, so for question C, part C, CAB. So CAB is actually this angle. Okay, I will denote it as theta. Okay, so now theta is actually the opposite side of theta now is 8, and the adjacent side is 6. So now we need to be flexible. Okay, so now for theta, so what I'll do is, again, I'll use tangent. So now it's tangent theta equals to opposite, which is the angle 8, length 8, and then my adjacent now is 6. So same thing, tangent equals to, key this in the calculator again, and you'll be able to get answer 53.1. Okay, this is the difficult method. What you can do, alternatively, you can actually 180 minus 90 minus 36.9, and it will give you 53.1. Okay, both answers is the same. But I want you to try this method because I want you to play with the ratio itself. Okay, I hope you were able to get the answer. It's fairly straightforward and simple. So moving on, the next question take some time again. Now we are only finding for the length itself. Okay, so look at the question. Give yourself 2 minutes maybe, and to complete this question. Okay, so moving on, AC. So the first question we are asked to find is to find length AC. Okay, line AC. So we actually have we have angle 35 degrees and then 5. Okay, so we want to find length AC. AC is actually the hypotenuse. So opposite, this is the opposite angle and this is adjacent. Okay, so now that we have we want to find H, we only have the A. So if we want to find H and we have A, so the first thing you will think of is actually cosine rule, not cosine rule, sorry, the cosine ratio, which is 35 equals to A first, so it's 5 over AC. Okay, so you rearrange. Okay, and you will get answer of 6.103SF. Okay, always remember your answer for length itself must be in 3SF, and then your degree, your angles itself must be in 1 dp. Okay, 1 decimal point. Moving on to part B, we are supposed to find BC, which is opposite. So now we have adjacent, and then we need to find opposite. So the first thing I'll think of will be the tangent ratio. Okay, so opposite is BC itself. Then my A is actually AB, which is 5. So I'll find BC. Okay, and the answer will be 3.50 3SF. Okay, I think it's fairly simple and straightforward, and you have managed to use most of the ratio, okay, and identify what the ratios are. So with that, I have come to the end of this video. I hope that you'll be able to remember all the formulas that is given today, and that you will be able to apply them easily. Do remember how to identify what is the opposite side and adjacent side. And with that, I have come to the end. Thank you. See you again.